So we're going to quickly go over these, not as much with the first two questions, mostly focus on the last, just to, try to build some classroom culture. Let's save. Open. All right. So, for the most part, recognizing linear, exponential, quadratic is where we feel the most comfortable solving equations, but I'll also point out we have 23 students in class, so we need to work on some of this. These are overall non-negotiables for being able to pass my class. We're going to talk more about some options for a handful of us who are still struggling, because I do not want you to give up. I want you to learn and grow, so we'll talk about that. What are we least comfortable with? Create an equation for a transform function when given a graph or a table. I figure that's where most of us would fall. We'll talk more about that later. So, can you let this board in, please? So, who's the person to your right? Their favorite part of spring break? I would be super hype about getting a car. Mitria, I respect the sleeping. I don't know if y'all know this. I usually wake up at 4:40 every morning so I can go to the gym and work out before I come to work. Before I come to work. So I got to sleep an extra hour every day, and it was nice. Good talk. All right. Mostly not being at school, going to the beach, fishing, going to is it Gatlinburg? Is that what that's supposed to be? Yeah. Gerald, did you go to Gatlinburg? Okay, gotcha. All right. I cannot believe I figured that out. So. If you did not have your textbook with you, can you quickly raise your hand so that Ms. Courtney can give you a copy of what you need today? Kyle, I respect the video games, and a lot of not going to school. I will say for myself, oh, by the way, does anyone have any late assignments that they worked on over spring break and they want to turn it in? So no? Negatory? If you have something and you don't want to say it out loud right now, go ahead and get it out and hand it to me later. I'm trying to remember. I think that's it for there. I will say personally for myself, I don't know how many of y'all actively watch anime, but one of my favorite animes is definitely Attack on Titan. I finally started catching up on season 4. Man, wild ride. Most of the other animes I've already finished, or I'm rewatching, like Yu Yu Hakusho. It's just good to have on in the background while I'm working. But if you like anime and you haven't watched Attack on Titan, you need to fix that. All right. So we're gonna have a quick reminder about rubrics. Open up to some questions before we jump into activity 2.1. A quick recap about transforming functions by non-constant values, and hopefully finish up that lesson 2 overall today. So quick question that I want to pose to y'all, because this is an important thing to think about, because I feel like a lot of us get down and get frustrated, especially in this class more than my other 2 classes. What's the point of school? What is the point of an education?
What's the point of school or education?
Yeah. Why are you here? We have to be here is a lot of times our mentality. Why else are we here?
You need an education to do something in life.
What does that mean though? Like,
No, you can't
what?
just drop out of high school. Most places you gotta have a high school diploma at least.
Okay, so for a lot of jobs you have to have at least a high school diploma. But why do jobs want you to have a high school diploma? I feel like
you ain't dumb. Then you too simple tags.
okay.
But you still can be dumb and pass.
But at least you got a high school diploma.
But what does the high school diploma mean? And like, I need y'all to understand this because I feel like we get distracted by the work a lot of times because there is work, but I need you to understand the point of school is not to just force you to be here. And I know that the mentality I have is not necessarily the mentality that you have for a lot of other classes or a lot of other teachers. It's not just to do work. I did have a couple of people email me over the break to say, hey, what work can I do to bring my grade up? And obviously anything you have a 0 on you could have worked on. But I want y'all to understand the point is not to just do work. It's not. It's not to do worksheets, it's not just to earn a grade, it's to learn. The high school degree has gotten away from this, but originally the point of having a high school degree, and this is why a lot of jobs now don't just require a high school degree, they require a college degree, is employers don't just want to know that you can make it through something or that you can just complete a task. They want to know that you know how to learn. They want to know that you know how to think. Because how many employers do you think are going to care that you know, or maybe you don't even know, the exact year that Christopher Columbus sailed across the ocean to get to the Americas? How many employers do you think are going to care if you know when to use a semicolon versus when to use a comma versus when to use a period? We got the internet for that. It'll literally tell you how to fix your grammar. How many of your employers do you think are going to care if you know the 3 different forms of a quadratic equation?
It would just depend on what type of job it is.
Yes, but also at the same time, I'm going to go ahead and tell you the vast majority of them won't. I need y'all to understand it's not just about accumulating knowledge, because all of that knowledge you can Google. Literally in your hands, well not in your hands because they need to be up there, but when you're outside my classroom, your cell phone will Google and find all that information anytime you need it. It's not about accumulating knowledge, it's about learning how to think with that knowledge. So yes, you need, in my class, to know the 3 different forms of a quadratic equation. Yes, you need to know how to write the equation of a line, but the focus is on learning how to think with it. Because remember, at the end of the day, what is mathematics? So, right, what is mathematics? Study of patterns and relationships. Gerald, what is mathematics?
Study of patterns and relationships.
Does any part of that say memorize information to make it through a class? No. It's to study, it's to explore. Remember, the first thing that mathematicians do is they do what with those patterns and relationships? It's been a minute since we've said it. Huh? They notice them. Then they notice, they describe, and then they generalize. Yes, Caleb?
We've been taught to memorize stuff since we first started, so that's what we're used to.
Oh, I
That's
know.
why your class is different.
I know. And I
That's what
get
they
that.
expect us to do now.
I know. And that's why I'm having this conversation. I want y'all to understand, I know that the expectation, for the most part, has been to memorize. Memorizing is the lowest form of education. It's the lowest, not education, of learning. And I know that that's the expectation that you've had forever, but I need you to also understand that that's not useful to you long term, which is why I don't want you to just do that. Okay? I struggle with the fact that a bunch of us are struggling in this class. I do. But I also know that if I just expect you to memorize things, it's not going to be good for your long term, and I care too much about you and your future to just have the lowest level of expectations for you, especially on top of the fact that I know every single one of you is capable of amazing things and amazing thinking. So I'm not going to steal those opportunities from you. You can do more. And so one of the things I want you to be aware of, I'm going to show you the rubrics in just a second, but I want you to be aware of this. I already even went down and talked to Mr. Hinton this morning, and I asked him, I was like, I have, especially in my first log, quite a few students who are struggling, but if I can get them to show me mastery sometime this quarter for content that we learned last quarter, can we work on that to at least help them earn a 60? And he agreed. So if you're at that point where you're like, man, I did not pass last quarter, you're not out of the hunt. I'm not going to raise grades when they're already passing, but I need you to understand, if you can put in the time and effort with me during class and maybe come in outside of class, and you didn't pass last quarter, you can still pass and be okay. But I need you to work. I need you to reflect upon the things that you're struggling with. Again, because it's not just about memorizing content, it's about learning and thinking with it. So, a couple of things to be aware of is, everything we did with transformations will show back up, not in the next unit that we're doing. I mean, it's in this unit a little bit, but in 2 units. So if you can show me mastery over a lot of the transformation stuff there, I can work with you. the stuff with solving equations and the 3 different forms of quadratic equations, that's gonna show up in our next unit. So if you can show me mastery there, you'll be okay. But you do have to show me that you are understanding and learning. You may have to come in to tutoring hours. You may have to go watch videos on YouTube, something. I'm here to support you to be successful. Let's work towards that. So what are your questions before we go over the rubrics and get started with today?
None.
Yes, sir.
So we basically going backwards in the algebra one. That's what the book is for, basically.
I'm not going backwards.
That's why this, like, ain't this the algebra one book?
No, this is algebra 2. There's algebra, it's volume 1 of algebra 2.
Okay, true.
We will probably not even get to volume 2. But a lot of what we are struggling with is algebra 1 content, so we're gonna not review, but it's built into the curriculum. So if you can show me mastery of old content, then we will work with you to earn that 60 at least. Yes, Brittany?
So, what if we're like trying harder this semester, but we're still like, we're putting the tutoring and stuff, but we're still a little stuck?
If
Like,
you're-
we
if
show that
you're-
we're trying, will we still?
If you are putting in genuine effort, there is not a way for you to earn below a 60. If you are putting in genuine effort, you will learn, you will grow, and I will watch out for you. But you gotta learn, you gotta grow. Those are the biggest things for me, okay? So, but as I said, if you master content from last 9 weeks, then we will work to make sure that you have that 60 to pass last 9 weeks, which makes it significantly easier to pass for the semester, because you just have to have a 60 for this 9 weeks, okay? But again, that's the whole thing, and I've said this since the beginning, I don't care when you learn it, I care that you learn it. So we got time, we just have to make sure that we're doing our best to learn and grow. So as a quick reminder, this is the scoring rubric that I'm using now, this is the updated one. So remember, it's all about your level of evidence of your understanding. And I want you to notice again, it's not mastery of memorizing, it's your level of understanding. When it comes to the active collaboration rubric, again, it's feedback to you about how well you're engaging in class. And so I bring these 2 things up because I want you to remember, nothing in my class is ever just do a worksheet and move on. It's about your learning. It's not about memorizing, it's about growing. And so when you look at these rubrics, this scoring rubric, this is to give you feedback on your understanding of that question and of that content. I will give back your 9 weeks exams. I got a couple students who have to make theirs up still, but you will see this. Don't just gloss over it and say, hey, I got a 5.5, that's it, or I got a 5 and a D and that's it. Please understand that this is feedback to you about the level of evidence that I see of your understanding. Because you should use that moving forward to help you grow and improve that understanding before the test. Okay? This is giving you feedback on your level of understanding, and that's the whole point. It's not just to get a grade, it's not just to get a 5.5 or just to get a 6. It's about, hey, this is the evidence I see of your understanding. And are you messing up with something that's a conceptual issue in your justification? Are you missing details in your justification? Or are you actually making an error in the way you're working it out? That's an important set of differences. Are you only referencing some relevant mathematical thinking, or do you have a decent start? That's the whole point, is to pay attention to what do these numbers mean. And so I'm going to have you get this rubric out when I have you take the exam or take assessments in the future. I will have you get this rubric out as soon as I give back assessments in the future to help you remember. And again, this is not just a grade. This is to tell you exactly what I'm expecting out of you to be successful. This is the quietest class I have all day, every single day. And it's also the class we struggle the most in. We don't talk much during the whole class discussion. And I get it, it can be scary, but I promise you'll learn more if you are putting your brain in gear to share out ideas. Alright? I need you talking within your small groups and being actively engaged on the content in front of you. So remember, when it comes to the small group side of things, what I'm expecting out of you is for you to share your insights, your thoughts about the presented problem or mathematical concepts, I'm expecting you to listen to and consider others' thoughts and perspectives, because that is going to help you grow and engage in the task and make sense out of what's happening. You are supposed to ask questions of each other's thinking to push for better understanding. Notice that's not just, hey, I'm completely lost, how do you do this problem? When someone shares an idea, right? When Mitria says, well, I think you should add here because we're trying to solve for x, right? Then maybe Caitlin goes, well, but it's already adding, so is that going to make a 0, right? Ask a question to push back on each other's ideas, to help each other grow and learn and move forward. We got to use that to take it to grow and to learn. During whole class discussions, remember I'm looking for actively sharing thoughts, asking questions, or taking notes. You got to do those things. So, here we are, lesson 2. I believe this is M1-139. This is where we stopped last 9 weeks. It's where we're picking up this 9 weeks.
This is last 9 weeks.
Yes, sir. Fourth 9 weeks, this is it.
Yeah.
139. Okay. Here, can you let in, please? Thank you. Alright, so please note, what we're focusing on is dilating functions by non-constant values. Can anyone share out what I mean again by a non-constant value?
Not answer the question.
139.
It did not answer the question.
A value is not constant.
Okay, but what does it mean for a value to not be constant?
It changed, the number changes.
Okay, so what do we have when the number is changing?
That's the change.
Yeah, maybe quadratic, but what's included in a quadratic? Okay, so let me ask this then. What is a constant value?
When the value stays the same.
Okay, what would be an example? So what kind of number would stay the same?
1.
Okay, give me another example. 2, huh? 2 would work as a constant. What else? 3.
4.
So what would be non-constant?
1.5.
That's constant.
Negative.
A negative what?
3.
Negative 3 is still a constant number. So that's still a number.
-1.5.
That's still a number.
So if it ain't a number.
Uh-huh.
Negative 3/4.
That's still a number.
Could it be infinity?
Say again.
Variables?
Variables. Variable expressions are when we are dealing with non-constant values. That can change, can't it? Yes, no, maybe so? Yes, thank you, okay. X squared minus 4. That can change, can't it? So when we're talking about those non-constant values, we're talking about variable expressions. Those are things that can change. Remember, we did a lot of this before the end of the 9 weeks. If we have the parent function x squared, x minus 4 squared, what did that do to the parent function? Okay, but what kind of transformation? Translation to the right. How much? 4. So first off, how do we know that would be a translation?
Because it's equal. On the inside.
It's not a translation because it's inside.
The equation. Subtraction or addition.
It's horizontal because it's on the inside of the main operation. What made it a translation? This is what got a lot of y'all. The subtraction. Remember, when you add or subtract, that's a translation, right? It's inside the main operation, so it was which direction? Horizontal. And everything horizontal, it acts the inverse. We need to be careful with opposite. Because remember, in this case, Gerald, it is opposite. But what would be the opposite of 1/2 in this case? What do we mean by opposite? Say again. See, the opposite wouldn't be 2 divided by 1. That would be the reciprocal. What is the opposite of 1/2? Negative 1/2. Remember, mathematically, the only thing that we mean by opposite is the opposite sign. That is it.
So when we're using like square roots and stuff, we apply to that.
So we can use the inverse of the square root. Remember, the square root is the inverse of a square. But that's why I say that, oh, are you talking about like when we take the square root to solve an equation? I got you now. So like x squared equals 4. So what would I do to solve this? Anybody?
Square root.
Okay, so the square root, remember, this, and so this is why we also can't just say opposite. The square root is not the opposite, the square root is the what of square?
The remaining?
Inverse,
Oh.
right? Remember the inverse idea is that it will cancel it out. So x equals what? 2, but,
And negative 2.
and -2, the opposite of that 2. Was that what you were referring to, Caleb? Yeah. So, the number 2 and its opposite. I'm getting some blank looks here. Does anyone remember why we get both of those?
You gotta remember to keep both now, because I haven't seen the calculator.
It's not, but why do I need both of those?
Cause the negative sign
Because
is
they both
negative.
work.
What do you mean they both work?
I don't know. I don't know how to put it in words.
Negative 2.
But what does that mean that they're
It
answers?
come out with a +4, both of
Because
them.
they
And
both
you
make
can
it
plug them in
true.
and get the same thing.
So what did you say, Caleb?
Because they both make it true.
They both make the equations true. Remember, when we say solutions, what we're saying is the numbers that make the equation or the inequality true. So it's not just like, oh, this is an answer, it's that it's a solution, it makes the equation true. And so, yes, you are correct, Jakayla, that the calculator will only give us the 2, right? But it's on us to remember that we can also have a -2, because they would both be solutions. We see how 2 squared and -2 squared would be equal to 4.
So that would work for any square root, not
Yeah, any square root you ever deal with, even with fractions. X squared equals 9/4. Okay? Inverse, x equals, and so I will point out, you can split this up and do this in your head. What's the square root of 9? What's the square root of 4? So you get a positive 3/2 and the opposite, negative 3/2. Both of those would make the equation true, every time. Okay? Ooh, that was a lot more review than I planned on there, but hopefully that helps us learn a little bit. So we're going to describe a relationship between linear factors of a function and its zeros. And this is where we're really going to focus right here, is intervals of increase and decrease on top of these zeros to get started. So remember, we looked at this, this is on the next page, 140 I believe. And this is where we did f of x equals 3 plus d. So what transformation did we have at play in this opening piece? Because f of x equals, because notice we had f of x equals 3, this line here. But then we added d to it, so what type of function did we get?
Vertical translation.
There we go, we had that vertical translation in there. How did you know it was a translation?
It's not in the main operation.
Okay, so is it not being the main operation, that tells us it's a translation? Listen and pay attention to the question. Is it the fact that it's not inside the main operation that tells us it's a translation?
No.
So you're completely correct on vertical translation, but a lot of us are getting this mixed up. What tells us it's a translation?
So I said it added to D.
There we go. We need to be careful though. The adding is what makes it a translation. It's not inside of a main operation, which is what makes it vertical. Okay. Then we got to here with 2.1, and we did a times x, right? So notice we had this function x plus y equals x plus 3. And then what we did was we did x times f of x. So what type of transformation was that?
Darling,
How'd you know it was dilation?
my notes.
Okay. Thank you, right? It's not just, oh, I looked at my notes. We got to remember the addition subtraction creates a translation. The multiplication and division will create dilations. What about if it's a negative?
Then it's a reflection.
It's going to create that reflection. So we want to keep those ideas in mind. They play into this a good bit. There was something else I was going to say here. Oh, one last detail, because this will help us move forward heavily. What did we do to help us do the dilation? What mathematical representations were we using? Tables. So we got to be careful. Multiplication is not a mathematical representation. Multiplication is an operation. right? But I believe most of us should have a table. You could have 1 or you could have 2, right? So x and then x plus 3, right? So -3, -2, -1, 0, 1, 2. You might even have more than this. But we can substitute that in for x, right? -3 plus 3 was 0, thank you. -2 plus 3. -1 plus 3. 0 plus 3. And I'll point out, again, math is the study of what again? Patterns and relationships. Anyone see a pattern so that I don't even have to keep plugging it in each time? It's adding by 1 there, right? 4, 5, 6. And so remember, the whole idea was that we were going to do x times x plus 3. This is the graph that we got. So we can just do x times x plus 3. Right? Just multiplying those two numbers together. What are your questions from here before we continue? Yo, is anybody else warm or is it just me?
No, it's
I
you
feel like I'm
stand
not
up, you
sweating.
stand up there.
I just barely turned it down. Alright. So, last quick detail I do want to point out is, you don't have to make a table. It's on you. It's your choice. You can do it graphically as well if you recognize that it's x times f of x. X times, what's another way to write f of x? Y, right? So x times y, -1 times 2 is -2. 0 times 3, right? So you can do that as well, just on the graph. And we do want to keep in mind, what type of function did we get out of this? Quadratic, right? And this was an important point that we discussed at the end of all this. When we did dilations like this, did it change the function? Sure. Did this ever change the type of function though? So remember, when we transformed by a constant, it did not change the type of function. When we dilated by, which was this function, right, y equals x. When you dilate by a non-constant value, does it change the type of function? Yeah, we took a linear, we multiplied it by a linear, and we got a quadratic. So we want to keep that in mind as we move through today. Hopefully that's a good little reminder, right? So we see it here as well. So what we're going to do is we're going to pick up on number 5 today. Now, I want to emphasize something. If you get stuck a little bit with this number 5, what could you do to help you move forward and make sure that we're not just sitting there stalled out doing nothing? 1, ask questions of your group, right? 2, I'll be coming around so you can ask me questions. 3, before you do any of that, actually, working within your small group, you should do this as well. Don't you have some notes on the previous set of questions? Yeah. Can you use that? Should you? You know, that's how you study too, right? Like you go back and you look at your notes and you use that to help you move forward. And I know it's been a minute since we've done some of these things, but please do notice, right? So now we have this function negative, parentheses x plus 3, that's already graphed here, and it's being dilated by x. So the fact that it's dilated means what mathematical operation? Multiplication. And so we're going to do x times h of x. Now, one thing I do want to remind you is, what are the two mathematical representations that you can use to help you graph this new function? You can use a table, and you could use a graph. Okay, so this could be very similar to what you did in the past. Notice you have some points, or you have a line here, so you can get some points already. Also, if I were to graph y equals x, how would I do that on this graph here? What would y equals x look like on this graph? What does y equals x look like on this graph? Because I would have that line as well. No ideas?
It's a diagonal line.
It is a diagonal line. So can I just do this?
No, you gotta get through 0.
Okay, so remember, every point on the line needs to make that equation what?
True.
True. So you said it needs to go through 0?
Yeah.
I assume you mean the origin 0, 0?
Yeah, 0, 0, 1, 1.
And keep going.
Keep going like that?
Yeah,
How'd you know that though, Anthony, so that everyone else can get there?
it's a linear.
Thank you.
Don't say that out
But how
loud.
do you know that it's those points?
Cause it made that true.
Okay, so we can check that, right? 1, 1, does 1 equal 1?
Yeah,
Yeah,
Yeah. There's 2, 2, does 2 equal 2?
yeah.
I want y'all to notice a pattern here. First off, literally, it's saying that the y value equals the what?
it's,
So, 2, 2, does the y value equal the x value? 3, 3, does the y value equal the x value? Negative 2, does the y value equal the x value? Also, I would remind you, you can think about your identities a little bit. What's understood to be multiplied by the x?
-1.
Not negative 1.
Oh, I thought you were talking about the other one.
1, right? What's understood to be added here if we don't have anything written out?
1.
Not 1, 0. Remember, multiplicative identity, additive identity, right? So this is a y-intercept of 0 and a slope of 1. All the things connect. And so there's your line. So at this point, I do want you to get started with your small group. Graphing. So the graph shows this function, negative parentheses x plus 3. Choose several points on h of x and dilate each by multiplying by the x value of that particular point. So you can use the graph like this. You can set up a table like this. Let's get that graph done and then answer questions 6 through 9. I think it goes all the way through 9. What are your questions before I release you to work within your small groups? Okay, I'm going to give y'all 3 or 4 minutes to get started. I'm going to come back and let y'all ask some questions if we're completely stuck as a whole. And then I'm going to let you get back to working. Let's get to work.
Negative